Good evening, everyone. My name is Reuben from the Zcoin project. I'm also joined by Paramin Insong, who's the founder and lead dev of Zcoin. And I'm here today to sort of give you a brief overview of privacy or privacy technologies that are available on the blockchain today. Someone did correct me to say whether it was privacy or privacy. I did check, both are correct. So, okay, so let's first of all, this is just a brief outline and I'll go straight into it. So a lot of people have been asking, why do we need privacy on the blockchain? A lot of people think that, oh, it's only if you have something to hide, you're doing money laundering or criminal activities. But that's not actually quite true, If you take a look, and traditional financial banking systems already offer some kind of privacy, Not anybody can check your bank balances or transactions, right? Only like authorities, tax authorities, police can do that. So there is a basic form of privacy. And blockchain raises a particularly interesting problem because all transactions on the blockchain are permanently and publicly viewable. So although you don't know who owns which account or address on the blockchain, you usually when you pull other different kinds of data, you can actually discern spending habits, and we will talk a bit more about that later. And another sort of a key aspect about privacy technology is the concept of fungibility, that one coin is indistinguishable from another. And we often, I guess the analogy would be cash. One Thai baht or 100 Thai baht is no different than another Thai baht, right? So for example, like in the US, there's actually a statistic that 90% of all US dollars have traces of cocaine on them. And, we're not going to say that anyone who has these dollar notes are involved in drugs because, the cocaine could have come through anyway, right? But with blockchain, it's particularly more concerning because everything's recorded on the blockchain. With cash, you don't know how many hands it's gone through. But let's say if there was a drug deal, and now I can exactly see the flow of the coins from the drug deal to you, and that's a potential problem as well. Your coins are tainted, and that affects the fungibility of your coin. So, and so if you think about it, cryptocurrencies in general aren't that great for money laundering, because at the point, most of people still need to convert to fiat currencies, like Thai baht, US dollars, and stuff like that. And you do this through exchanges. You do this through, OTC counters. And most of these places would require KYC AML. So, know your customer, anti-money laundering laws. So if you want to sort of, money launder large amounts of money, I don't think cryptocurrencies is the best way to do it. So here we're talking more about, financial privacy as a basic right, okay? So first of all, let's cover privacy in Bitcoin and why it isn't enough. So when Bitcoin first launched, it was like promoted as a private type of currency. And, So the conflict is that blockchain is about transparency, right? Every single transaction is permanently visible so that everyone can verify balances. And yet we have to kind of keep privacy. So it's like privacy in a transparent system. And that's why it's not easy to do it, because how do you maintain transparency while maintaining privacy at the same time? Great. Okay, and actually basically, Bitcoin is not anonymous, it's actually pseudonymous. So you can see what the person is doing, but you don't know who it is. It's like writing a book and, with a pen name, so I'm not going to use my real name. So I can see what that guy is doing, but I don't know who wrote it, right? So people can create a new Bitcoin address for every single transaction so that I can't tie the behavior from a single address. But that's not quite enough, as you will see later. And this is because of the rise of blockchain analysis. And blockchain analysis basically uses that we are humans. We have predictable behaviors, We make periodic repeat transactions. We buy from the same stores. We do the same things. And we're all creatures of habit. And we also transact with entities that actually know our identities, our exchange. All exchanges, almost all major exchanges now know who you are. You know, when you pay on BitPay, when you pay on Coinbase, they might record your IP address. So all this information combined together, when you use it with the blockchain, suddenly, you know, Bitcoin isn't as, you know, private or anonymous as you previously thought, because once you pull all this data together, you know, you can find out who you're dealing with. And at the same time, because everything is permanently recorded, you have all the time in the world to analyze, right? Because it's all there. And there's, you know, a couple of blockchain analysis firms, Chainalysis, Elliptic, Numisite, Scry, and all these companies are dedicated to finding the real-life identities of particular Bitcoin addresses. And you can see that it's all about the relationships between addresses. When you transact with someone, there's a certain relationship between addresses and the transaction flows. And from that, you can determine the real-life identity of someone. Now, there have been proposals to improve Bitcoin privacy, and I think these are the two main ones. There might be others. But it was like stealth addresses and payment codes. Well, for the purposes of this talk, they're kind of similar but different, as the Thai say, same but different, okay? But, you know, instead of creating a new address all the time, because like right now, let's say if I want to, you know, do that, give a new address all the time, I every time have to give you a new address, and I can't just post my Bitcoin address on my email, because anyone can just take that particular address and see every single transaction that has been on it. And that's quite a problem. Like, I don't want other people, my competitors, to know how much I'm receiving, right? So what stealth addresses does is that now I can give out a public address, but when people pay to the stealth address, then it automatically creates a new address. So it's just basically a convenience standpoint, but it doesn't offer any additional privacy from someone that's just giving a new address all the time. Now, confidential transactions is a bit more interesting. It actually hides the transaction values in the transaction. So for example, if I'm transferring from person A to person B 1 Bitcoin, confidential transactions hides that you've transferred 1 Bitcoin. But you still know that person A transferred to person B. One of the sort of drawbacks of confidential transactions are the large transaction sizes. And this is also probably why it's taken so long for Bitcoin to even bother adopting this. They're more concerned about scalability than privacy right now. Because you can see 16 times Bitcoin transaction size. There's been recent developments. There's a new compressed version that's only 3 times Bitcoin transaction size. But we'll probably have to see some other coin adopt it. I believe Charlie Lee from Litecoin has been expressed some interest in implementing this. But it still doesn't offer privacy because, you know, even Ian Mears, a very respected guy, and he says confidential transactions are neither confidential nor transactions because you're still not hiding that A transacted with B. So, you know, the sort of example he gave is that we know you pay for hand size enhancement surgery, just not how much. We just don't know how much you paid. So it's not a complete solution. So the first kind of sort of anonymization of privacy technique are coin mixers and tumblers. And these sort of existed especially on the dark net where people want to hide their transaction flows. And with the first kind of Bitcoin tumblers, it's basically kind of like mahjong, you know. You take all these coins, everyone puts in coins, mixes them up, and takes the same number of coins that they put in. And, you know, so basically by doing this, the trail becomes obscured. You know, I could be any of these people. I can't exactly tell the trail because I've just mixed it with everyone's funds. But the problem with this sort of mechanism was that you kind of have to trust the tumbler during those early days because, you know, you have to trust that the tumbler's not going to run off with your money. You have to trust that the tumbler's not recording your IP address. And so there was a problem, and this is why there was CoinJoin. And CoinJoin, you know, there was used in Amitaki's dark wallet and a modified version in Dash, which was called Dark Sand or Private Sand. So it's a modified version. And this solves one of the main problems by the tumblers now can't steal your money. So that's a really big improvement. There's actually also another type of tumbler called Tumblebit. I think it's implemented in Stratis in your Breeze wallet. So it's a kind of similar type of solution in the sense that you don't need to trust the tumbler anymore. They can't steal your money. Now, the pros of this tumbling approach is that it works on top of most currencies without any sort of modification in code. So you can use it on Bitcoin, you can use it on Litecoin, you can use it on anything without any sort of major change in code, right? and it's relatively simple to implement. There's no advanced cryptography. It's just people mixing money with each other. It's no big problem. And it's relatively lightweight because it's just basic Bitcoin normal transactions. But the cons are, it's limited by the number of people you're mixing with. So, in the mahjong table, it's limited by the number of people on the mahjong table. And it requires mixers to be online. You can't mix with someone that's not online or with actively wanting to mix, which kind of reduces your anonymity. And it requires liquidity. You need funds to mix with. If no one wants to mix with, if you've tried Dash in the early days, when you want to do a dark send, you kind of have to wait for people to want to mix, and that may take days. So that's a sort of a con to this type of mechanism. So we'll move on to something called ring signatures and CryptoNote, which is a really interesting technology. It's used in Monero and Aeon as well. And basically, it doesn't use Bitcoin's base at all. It's a completely new code base. And ring signatures actually means one person signs from a group and you can verify that someone from that group signed, but not who did it. So actually the very common sort of use case is that, there's a bunch of White House officials, the president, the vice president, and this particular order, it came from this group of people, but you don't know whether it's from the president or the vice president. I don't really like this example, actually. I prefer to sort of think about it. If you're in a room and there's a group of 5 people and someone farted, and, it's like, yeah, I know it's one of you, but I'm not sure which one of you. And that's basically it, right? It's easier to understand like that. So CryptoNote's really interesting the way it works, because when a user wants to send a transaction, it doesn't use other people's funds to mix with. It actually auto-scans the blockchain for other outputs to use as dummy inputs. So basically, when I form the transaction, I'm finding other people to fart with, right? And then when funds are sent, the sender randomly chooses the user's funds as possible sources of funds to be spent. No one can tell which one is the true source of the fund, because it could be any of these guys. And other users can also use your funds as their dummy sources. So it's automated mixing. I don't need the person to be online. It just does it, and you can see the GIF is really cool. It could go in many ways, so there's a lot of plausible deniability, all right? Oops. And CryptoNote's really awesome. It's like there's no need for a mixer. Mixer happens done automatically. Monero implements privacy on by default. That means all transactions are done through this mixing. And anonymity actually increases as time passes because as more and more people use your outputs as their dummy inputs, it becomes more and more difficult to find out the true transaction flow. And now it even hides transaction amounts. So like remember in confidential transactions, so you also don't know how much is being transacted with ring CT. And it's using very well-researched cryptography. You're not using any novel new cryptography on top. But the major con of Monero and CryptoNote type of currencies is that there's a lot of scalability issues. Like if you think Bitcoin has a problem, with its 1 megabyte blockchain, Monero with ring CT each transaction is 15 to 25 kilobytes. Compared to Bitcoin, it's 50 times larger. So if you think about that, if you want to reach like sort of Bitcoin level transactions, that's going to be the problem. And unlike Bitcoin, which you can prune, Monero, you still have to keep the complete blockchain. So, as time passes, more and more storage you require, and there's no way currently to reduce the size. And because Monero uses a sort of a very unique system, it doesn't use a Bitcoin base at all. It requires a lot of separate integration work. So if you take a look at even though Monero is really, I think it's probably the top privacy currency with the highest market cap right now, there's still a kind of lack of integration. The Trezor doesn't support it. I'm not sure if Ledger supports it right now. Yeah. And the ring size is practically limited. Monero uses 5 by default. You can choose higher ring sizes, but it will only scale to to a 50, 25 or something. It's not going to be in the hundreds or thousands, all right? And another sort of a controversial thing is that quantum computing will retrospectively expose. So when quantum computing comes off, of course, the least of your concerns would be cryptocurrencies, but meaning that with quantum computing, now I can tell exactly who farted. So yeah, that's it. Okay, so here comes zero-knowledge proofs. So Zcoin and Zerocash, they are different protocols despite the similar name, but they work on similar principles, right? So what's a zero-knowledge proof? So the sort of classic type of sort of illustration of what a zero-knowledge proof is to prove that I know a piece of information without giving out that information itself. So if everyone can see on, there's this little cave there, and there's a little secret trapdoor in between A and B. How does Peggy prove to Victor that I know the secret passcode to that secret door without telling Victor the passcode, right? So in this case, basically, Victor says, okay, Peggy, you go into the cave, you come out from A or you come out from B, and he will just randomly say A or B, A or B. And Peggy keeps on coming with the right, she keeps on coming out from the right version. When Victor says A, she comes out from A. When Victor says B, she comes out from B. And you do this like millions and millions of times, you're pretty sure that Peggy knows the passcode to that little secret door, but she has not revealed the passcode. So this is what a zero-knowledge proof is about. So how do you use it in the cryptocurrency, right? So this is using Zcoin as first implemented by Zcoin. And usually what happens here is that a user takes a certain number of coins and destroys this coin, completely burns it up using a Zcoin mint transaction. And at any time in the future, he's like, okay, I want to redeem my coins back again. I redeem this coin, so let's say if I burn 10 coins, now I want to redeem this 10 coins back. When I redeem those 10 coins, these 10 coins appear as completely new coins with no transaction history. So how do I show that I'm entitled to these 10 coins? I need to show that I previously burnt these 10 coins. If I didn't burn these 10 coins, I cannot be entitled to redeem these 10 new coins. And this is where the zero-knowledge proofs come in. I prove that I burned the coin without showing which coins I burnt. And this is what zero-knowledge proof is about. Okay? So unlike in CoinJoin and CryptoNote, which are limited by the number of people in the room, on the farting sort of analogy, and merely sort of hiding your transaction with that group of people, the method of burning coins and redeeming them later completely breaks the transaction names, because basically I'm creating new coins with no transaction history. The drawback with this type of setup is that there needs to be, during the initial phase when you're creating a zero-coin setup, you need to create certain initial parameters, and that you need to destroy these parameters. So, Zcoin uses something called RSA factoring challenge. It was hosted like in the 90s, many years ago, and there was a huge bounty of like $200,000 to break that. And they took certain steps to make sure that those parameters were destroyed. And the parameters are quite simple. They're basically two large prime numbers. And okay, so what happens if this prime numbers are leaked? If those parameters are leaked, coins can be forged. That means people can redeem new coins without a previous mint. That means I can generate new coins, but not have burned them up before. And this is a real problem, right? However, anonymity is still preserved. So even if I have these parameters, I still can't break the anonymity. And however, with Zcoin, because forgery can still be detected because of supply auditability, because I can see the number of coins going into the Zcoin network, and I can see the number of zero coins going out. As long as they check out, I know that the supply is still correct and there's no one forging coins in infinitum, all right? So, okay, let's look at the pros and cons of Zcoin. There's no need for a mixer, it's all built into the protocol. So it's a very high anonymity. So, basically instead of your anonymity set being of like, a couple of people in the room, it's now the analogy is that my anonymity now is with every single person that's ever farted before. So, if I have, farted before, then I'm in that anonymity set. And it retains supply auditability, and it uses very well-researched cryptography. I think everyone's heard of RSA, So, if RSA breaks, the least of your concerns would be Zcoin. The cons are proof sizes are currently large, so if you want to do a zero-coin transaction, it's about 25 kilobytes. There are ways to reduce this to 10 kilobytes. We're researching on ways to reduce this to 1 kilobyte. And it requires a trusted setup, okay, and incorrect implementations can leak, or leakage or trusted setup can lead to the forgery of coins, which I mentioned. And another sort of drawback is that you kind of need to be careful when you do your zero-coin mint and spend. That means you need to be careful when you burn and redeem. Some people are a bit silly when they burn the coin. Once it's burned, they immediately redeem it. Then, if you always do that, even though you have this, theoretical anonymity, I can say, look, every time you burn, every time you spend. So just a bit of common sense. Burn it whenever you want, and when you need it, then you spend it. All right? So now let's take a look at zero cash. Okay, zero cash uses really advanced cryptography, and it was meant to be an improvement over Zcoin, because Zcoin you still need to convert back to the base coin. That means when I burn it up, I can't transfer my burnt balance to someone else. I still need to convert it back into Zcoin, right? And so that means it also hides the transaction values. It's very small proof sizes. That means it's less than 1 kilobyte. It's a huge improvement over Zcoin, and it's very quick verification times. However, one of them, it's not perfect. It requires a very complex trusted setup. They actually had a really, I don't know if you guys are familiar with the Zcash trusted setup ceremony. It was 6 people. They went into the desert, and basically they had to destroy the parameters. And we are trusting that these parameters were destroyed correctly, because so to achieve small proof sizes and verification time, it uses experimental cryptography called ZK SNUGs, and I don't think it's used anywhere else besides Zcash. So there's not a lot of research into it, and I think most cryptographers, even people like Peter Todd, says that the cryptography is relatively weak. And the trusted setup is also very is complicated. It's not just 2 numbers. It's like a few gigabytes of data. Involves a multi-party computation. And there's been a lot of controversy, which I wouldn't go quite into it, but it's been controversial enough that Peter Todd, who was also a participant in this ceremony, decided to take down his blog post about it because he didn't want to have anything to do with it. And similarly, like in Zcoin, if these parameters are somehow leaked, or if there's a problem with the cryptography or a problem with the trusted setup ceremony, then because of the way it's particularly set up, if someone is secretly creating this, burnt state coins, or like what they call it, creating balances in the shielded addresses of Zcash, you cannot tell. Someone could be making billions and billions of Zcash, and because you can keep them in that burnt state, you cannot verify, and the supply is not auditable. So although it provides a lot of privacy and anonymity, but it's using experimental tech, and then when something breaks, it's very hard to detect. Of course, there's been security audits, but we've seen the DAO, we've seen parity. No amount of security audits can guarantee that there's no vulnerabilities in things. So actually, Zcash thinks actually is a really important problem. So they're working on something called ZK SNUGs, which is the successor to ZK SNUGs. And it uses better cryptography, that means more tested cryptography, not so weak, and no trusted setup required. However, currently it's not usable because each of these proof sizes are a few hundred kilobytes. So there's no way to use it in a functional currency. So I'm really excited to see where they take that from that. Oh, struggling with this. Okay, so basically this is, concludes a sort of like a broad working knowledge overview of privacy technologies on the blockchain. And it's increasingly important because now you have all these blockchain analysis firms. And we have to remember that it's not about hiding illegal activities. It's about preserving fungibility of a currency, preserving the sort of censorship nature of cryptocurrencies. And if we take a look at all this type of technologies, to achieve privacy, you often have to sacrifice scalability and usability. Like, if you've used a Monero wallet, there are additional steps that you need to do, all right? So there needs to be a sort of a balance, and all these different sort of anonymity mechanisms, they are with merit. They have certain different trade-offs. There's no one privacy technology that does everything. You want it more private, maybe you can use more experimental cryptography, or you want it like CryptoNote, then you have to deal with scalability issues. Right now, there doesn't seem to be a technology that solves everything. And so the kind of analogy that I like to use is that, yes, there's lots of cars. There's someone who likes the Ferrari that goes really fast but eats fuel like nuts. Or you want to use a Civic, that does your job reliably and, but it's not so sexy, right? So I just want to sort of cover this. I wouldn't name any coins, but there are a lot of coins out there that claim privacy. I'm a privacy coin. And yet they do not provide blockchain privacy. They'll just have something like, we use Tor, we use I2P, and this protects us. No, that's total rubbish, okay? And make sure that you always check that their privacy mechanisms have vetted academic papers on them. You have all these privacy coins, they have their home-baked sort of systems that are only vetted by themselves. And a lot of them even use centralized mixers that are controlled by the developers. So be careful of this. It's very easy to buy into the hype. There's actually one other upcoming cryptocurrency which I won't cover too much, but it's called Mimblewimble. It's really interesting. So take a look at Mimblewimble and grin. I'm not related to it, but if you're interested in learning about that tech, I suggest you Google it. Okay. So, what's this? I think. All right. Yes, so basically we're in the questions and answers section. So if anyone have any questions, and maybe Parliament would like to come up as well. Yeah.
Quick question while we're waiting for the mic to come around. Where can people get a copy of your slides? Because what you covered was very interesting but quite complex. So do you have somewhere on SlideShare or somewhere else they can get a copy of your slides?
Yeah, sure. I'll upload it later and I'll get someone to distribute it. Yeah.
That would be great. Thank you. Do we have some questions from the floor?
Any question regarding Zcoin space protocol? Anything like Zcoin? Or still confused?
People want to keep their questions private and anonymous. There's one over here.
No one wants to tell who farted. Yeah. Yes.
Yeah, we'll keep that secret from everybody.
Okay, thanks. What about Znote?
Znote. Well, Znote, for those of you who don't know, this is basically like a dash masternode system with Zcoin. It's meant to be a way to scale Zerocoin in the future because Zerocoin transactions are particularly big, they're 25 kilobytes big, and also computationally incentive. So we decided to have a sort of incentivized node structure. But yeah, that's not quite the topic of what we're dealing with today. But yeah, do check out zcoin.io. You know, we have the Z-nodes launching probably this month. So yeah. Thank you.
I think there might have been another question over here as well. Does someone else have their hand up?
To what extent do you think quantum computing is going to make anonymity retrospectively irrelevant across all anonymization?
Well, it doesn't make everything, it doesn't break everything. Like for example, if you use CoinJoin and whatnot, it doesn't break the anonymity there. But if you are using cryptography, like I think for example, with confidential transactions, if you use like discrete log, quantum cryptography with Shor's algorithm actually breaks that. So there are only certain types of cryptography that are broken by quantum cryptography. And the cryptography that's used in Monero, which uses key images and stuff like that, will be broken by quantum cryptography. Now with quantum cryptography in Zerocoin, RSA is indeed broken, but because it doesn't actually break the anonymity set, it's a bit technical on that side. But doesn't mean that quantum computing will break all anonymity. There are certain mechanisms that are more vulnerable than others. Monero is particularly vulnerable because you can retrospectively de-anonymize the whole blockchain. And like especially, there was this other sort of Monero clone called Shadow Coin. And they had like a bug in it, which was retrospectively expose all the transactions. That means I know who exactly farted. So yeah, it doesn't affect it equally across the board.
I'm loving this fart analogy, I have to say. One last question. Yeah, lady at the front.
Whoops.
Hello, that was a really interesting presentation, and I love the idea of being anonymous on the blockchain and with the payment especially. So I've been following you guys because I'm particularly impressed with the fact that the developer or the founder of your project is a Thai person.
Yes.
So being a Thai person as well, go for it. But anyway, recently I heard that you got a fork. Have you completed the fork?
Oh, you're talking about... So actually, there's a lot of like...
Recently, what exactly was done during that fork?
Actually...
or are you in the process of having it
during
forked?
that fork, it's like there's so many fork in our coin actually. And during that fork is something that we found the bug inside our implementation, and we detect that early before the hacker saw it. and we fixed the problem and we pushed the code up. Turned out that when we put the code up, the hacker itself like take a look what we patched and try to like repay that attack. And then that's why we need to have another fork that like suddenly close the attack, close the vulnerability before support. Like we expect to wait for like 2 weeks. Turn out we need to fork before that. That is something that.
Oh, I think I can answer that. So basically, Zcoin is the library that does all the cryptographic functions of Zcoin. And basically, you know, since it was created by the guys that did Zero Cash, there has actually been no modifications about it. And recently, when we hired our cryptographer, Tim Ruffing, to look at it, he actually found several bugs with the Zcoin. And he's like, okay, let's fix this. And what happened was when we were fixing it, because we're an open source project, when we update that particular piece of code, it requires a hard fork. And everyone's like really, oh my God, hard fork. No, basically a hard fork basically means that everyone has to upgrade to the new version. You know, it's not quite a big deal, especially with a smaller coin like us. Like Monero hard forks all the time. It's no issue. Ethereum hard forks all the time. Well, besides the Ethereum Classic fork, but you get what I'm saying, okay? But so what actually happened is that there was a vulnerability in Zcoin, and we found it. We tried to patch it, but we wanted to do it in a way we posted the thing up. But before the hard fork came into place, someone looked at our code and like, I'm going to take advantage of this vulnerability. And we managed to sort of stem the issue so the damage wasn't that bad, and we're going to burn these coins anyway, so it's not going to be a problem. But we're still maintaining, you know, that we're not going to like, you know, forfeit the hackers' funds or anything like that. So I think this actually particularly highlights this type of cryptography. It's really hard to get it right. And we could detect it because we maintain supply auditability. We could see, whoa, these coins are being generated out of thin air and something's not checking out, right? And because of this, we know there's a problem, right? But with like Zcash, you know, yes, of course, they have really a great team on top of it. But how do we know that there's no problems in the future? You know, is there a way to verify that this thing isn't already happening on their coin? And that's why, you know, I feel that Zcoin offers like kind of an in-between balance where we're using proven cryptography, you know, with supply auditability, so that if there's a problem, we can detect it. And I think it's really important. That's often overlooked. Not sexy, but an important point. Yeah.
Thank you so much, Reuben.